So we have talked about the scientific method. We've discussed the steps to it. Hopefully you have a bit of an understanding about how you do the steps of the scientific method in order. I told you that it doesn't matter what science you're dealing with, biology, chemistry, physics, geology, you use the same steps. Okay. But if you are working on medications, especially for humans, which we all are, things get a little bit different. Right? When talking about medications for humans, you have to do something called clinical trials. Now, clinical trials are a way that scientists can create new treatments, medications, vaccines, things like that for people. Because when you're working with humans, you have to do some things a little bit differently. I can't just go round up a big group of people, throw them in a cage and start sticking needles in them. Okay, they would arrest me. And they should arrest me if I do that. Right? So you have to do things a little bit differently when you're working with humans. Okay? And we call the way that we do science with people clinical trials. So these are scientific investigations of a new treatment that has shown some benefit in lab studies. Usually they have started with things like monkeys or mice or pigs, okay? But it's not yet been proven effective and safe for humans. So when you're doing these experiments, there are several things that you've got to consider, okay? Again, you can't just round up a bunch of people, throw them in a cage, and start shoving medicine down their throat, okay? That's not the right thing to do. You do it the right way, you do a clinical trial. Okay? The first thing that you always have to have, and y'all, this doesn't matter if you're talking about humans in medicine, or if you're talking about bacteria, or if you're talking about physics and chemistry, you got to have a control group. Now, a control is a standard of comparison for checking or verifying the results of an experiment. If I were to take a plant and put it in some dirt and start pouring fertilizer on it and that plant got huge, I can't say, hey, the fertilizer made it big. I don't know. What if that plant just got big on its own? You don't know if you don't have a control. So if I really want to know if the fertilizer made that plant really big, what I got to do is I have to plant one plant in the dirt and leave it just dirt. And I want to plant the exact same kind of plant that's the exact same size right now in another pot of dirt and put fertilizer on it. And now I see if the plant with fertilizer gets bigger. The one without fertilizer is my control. I'm seeing how big the plant gets all by itself. And then I'm going to compare that to the fertilizer plant. So it's going to help you check your results. So for example, if you want the experiment to be actually worthwhile, if you want to be able to say this is what did it, you're going to have a control group. Now, when you're working with people, to create a control group, you need something called a placebo. All right? Now, a placebo is an inactive substance given to a patient in order to compare its effects with those of a potential drug. There's a reason why we need a placebo. Okay? Scientists the world over have noticed that some people are able to create things in their minds that actually affect their physical body. Scientists don't understand how this happens. They don't have any clue why it happens. They just know that it does. And so someone who thinks they're getting a medicine might actually get better. Why? We don't know. Okay? But sometimes all you have to do is think that you're getting a medicine to get better. And so if you're not getting anything and you're sick, well, you feel bad. Okay? And if you're getting the medicine, you might be getting better, but what caused the difference? So we use a placebo. It's a fake medicine. A lot of times they use a sugar pill. If you're giving one person a pill that has medicine, you'll give the other person a pill that's just sugar, okay? So this makes a person think that they're getting a medicine, even though they're not. And this is how you create a control group in an experiment with people and medication. All right, you got to have a placebo. Again, you can't get a group of people together and say, okay, will you test my medicine for me? And they go, yeah, we'll test the medicine. And then you look at them and you go, sorry, you're not getting anything. Tough luck. You cannot do that. You got to have a control group. They need to think that they're getting a medicine, whether they are or not. And so you give them a placebo. All right. Now, when you're working with medications, all right, one of the things that you are going to have to deal with is trade-offs. Now, all of you have seen the commercials for medication on TV, and they ramble on about the side effects. This may cause this and 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 this. Okay, but it's going to cure you. All right, you might get sick to your stomach, you might have diarrhea, you might throw up, you might break out in a rash, maybe you'll have ringing in your ears, you'll get dizzy and your hair will fall out, but your disease is going to be gone. Okay, this is trade-offs. Okay, a trade-off is any desired outcome that must be given up when one option is chosen over another in a decision-making process. To put this in terms of your real life, we all deal with trade-offs all the time. Okay, anytime you have a choice to make between two different things that you want to do, you're dealing in a trade-off. Let's say on Friday night, the football game is happening, and you want to go to that football game, but you just moved to Milledgeville from Atlanta. And on that Friday night, your best friend from Atlanta, who y'all used to do everything together, says, hey, I want you to come spend the night with me, but I can't have you over any night but Friday night. Well, here's the football game that you really, really, really want to go to, and here's your best friend from your old school who really wants you to come over. Cannot do both. You got to make a choice. Whichever one you take, you're getting something good from it, but the one that's lost is your trade-off. All right? So for every good, there's usually some bad. Maybe a headache cure is going to give you an upset stomach. I take the pill, my headache's gone, but it upsets my stomach. Okay? You have to decide what's worse, an upset stomach or a headache. All right? And those would be trade-offs. Another thing that's always got to be considered when you're working with humans is ethics. All right, incredibly important. This is the principles of conduct that govern an individual or a group. All right, are you doing the right thing? Is this right? Okay, how you treat people, how you deal with them, what you do to them, you should always do the right thing. And that's ethics. Ethical practices should always be observed when doing experiments. No matter what, you should follow ethics. All right, another important thing when working in any scientific experiment, it doesn't matter if we're dealing with people or plants or puppies, doesn't matter. Sample size is important. And the thing about sample size, which is the number of observations in an experiment, the thing about sample size is that the larger the sample size, the better the experiment. Y'all, in science, bigger is better. Okay? Why would I want to only do 10 people for medicine to see if it works if I can get 100 volunteers? 100 is better. But why would I stop at 100 if there are 1,000 people who are willing to do it? 1,000's a lot better than 100. The more times you can do the test, the experiment, the more likely it is that the results that you're getting are going to be true results. That they're actually going to be the results that show you what is really happening. So the more you do the experiment, the better. So bigger is better in sample size. All right. Now, when you're doing these experiments, again, doesn't matter if you're talking about people, plants, or puppies, you want to do a controlled experiment. These are always the best. Doesn't matter what the science is, biology, chemistry, physics. Again, you want to set up a controlled experiment. Again, the control group, that's the one that gets the control, so the standard in which all the conditions are kept the same. These are the ones that are not getting the test. So this is that plant without fertilizer. How big is it going to get? All right. Then you have the experimental group. That's the group in which all conditions are kept the same except for one that is being tested. Remember I said we're going to have two plants. Both of them are going to be the same type of plant. Both of them should be the same size when you start. Both of them should be the same age when you start. You need to put both of them in the same kind of dirt. You need to put both of them in the same sunlight. You need to give both of them the same amount of water. And then you're going to put fertilizer on one. Just one gets the fertilizer. That's the experimental group. The one thing you're testing is fertilizer. All right? And then the experimental variable is the condition that is being changed. Fertilizer, if we're talking about the plants. All right? So that's what's being tested. We're testing to see if fertilizer, okay, will make the plant grow bigger. So fertilizer is my independent variable because that's the thing that I, the scientist, am testing. Okay, the fertilizer is my independent variable. Now, in a controlled experiment, only one condition is changed. I've added fertilizer to my plant. All right, and when I change that, the independent variable, okay, that I've set, I'm going to be watching to see what happens because I made that change. That is a second condition. So observations are then made of that second condition that is caused by the change to the independent variable. And that is the dependent variable because it depends on what was done. So let's talk about that plant one more time. I got a plant with the same soil, same plant, same sunlight, same water. And I've got a plant, same soil, same type of plant, same sunlight, same amount of water. And that plant over there does not get fertilizer. And this plant gets fertilizer. Fertilizer is my independent variable because I'm testing fertilizer. And then I'm going to see how much the plant grows. The growth of the plant is my dependent variable because how big the plant gets depends on my fertilizer being added. That makes it the dependent variable because it depends on me adding fertilizer, which is what I'm testing. All right, so that's how you tell the difference between the dependent variable and the independent variable. The dependent variable depends on what I'm doing different. I am adding fertilizer, my independent variable. How big the plant gets depends on the fertilizer. So plant height is my dependent variable. Now, for an experiment to really be good, we talked about this when I talked about setting up the steps, step by step when you do your experiment. When we talked about scientific method, has to be reproducible, must be able to be performed again and again. That's why it's so important to write your procedure clearly and precisely so someone else can do it again and again. All right, hope that gives you a little bit more information about working through the experiments and some of the parts. Again, email me if you have questions. Ask me in person is even better. All right.